Hi everyone, this is Steve Christensen. Today we're going to talk about Chapter 3 in the Water Treatment Plant Operations Volume 1 book, which is Reservoir Management and Intake Structures. Rio Dell, it's down on the edge of the delta. Many of you have probably been through there. But what do they use for their intakes? Now we know they're drawing out of the delta, which all those areas down there do. But let's see what they do. Oh, they used to use little tiny hoses that went in. About 1-inch diameter, banded together with some very crude filtration on the end of it. Again, the crude filtration obviously is to keep from debris sucking into your intake, which means that that's headed to your treatment plant. So it's pretty amazing that a little town like this could have run off of such a primitive supply for all these years. But several years ago, they decided to put in a new system. What does that mean? Well, we're going to get rid of this. Very unsanitary, very unstable, not something for the longevity, and probably highly illegal with the primacy agencies. Water pipes and conveyances are supposed to be buried to avoid potential breakage and contamination that could break into the system. So we have a new project going. Again, millions and millions of dollars on water infrastructure projects. They're normally either federally or state funded, which means they're prevailing wage. So even the private contractors that are doing the work have to pay prevailing wage, which is a very, very expensive way to build things, but it's the way our government works. With that being said, prevailing wage was set up to go ahead and protect the workers to make sure that they were getting a fair wage. Prevailing wage typically will at least double the cost of a project if it does not have prevailing wage versus having to utilize prevailing wage. It adds a lot of layers of complexity and expense. Okay, it looks like we've got a pretty big project going. You know it. So you certainly see the river coming down through here, as far as, and you see obviously the size of what they're doing is very substantial. A lot of environmental concerns and regulations when they're doing this type of work. We got a big hole going down here. And again, one of the things that we've talked about is safety. And one of the things we're not seeing in this excavation through these slides is really adequate safety. So, again, this is all suspect that OSHA would have come down and pounced on these guys big time for operating an unsafe construction site. We know that we certainly have to have shielding or shoring or, if nothing else, a 2-to-1 slope back from any excavation. And we're not seeing it certainly on this. But you can see the size of the ring, and that's the bottom of the intake. So again, going from those little 1 or 2-inch straws that they had up to this new huge intake is a huge increase in the capacity and what they can do for that system. One of the things that's going on with the regulatory agencies and the State Water Resources Control Board is they're actually trying to go ahead and consolidate small systems. In the state, we have over 10,000 small systems at this point. The state would like to see that number go down substantially because the small systems are the ones that are so struggled because of the economics. The more hookups you have on a system, the more economically that system can run. So again, you get these small systems with a couple hundred or 1,000. They're really inefficient systems, and yet oftentimes there's no choice. So again, you can see the size of this new intake with multiple pipes coming in and out of it. And again, interestingly enough, you can also see conduit in there. So you've got conduit on the inside of the pipes which control the pumps and all that kind of good stuff. Also. So again, very complex engineering. But again, I'm looking at where's the 2-to-1 slope. It's not here. Okay, where's the shielding? Where's the shoring? Now, one of the things that you don't see in this picture, which we will in the next one, is this is actually where the lake is right here. Think about a breach, breaks through. This guy better know how to swim. So again, very dangerous site the way this was being built. There you can see, see that waterway coming down. So you're below, the top of the waterway. Not a good scene. But anyway, that gives you an idea of the scope of this. We're looking at probably 18-inch pipe there, and there's two of them going down through that length. There's their new intake screen. And you can see, you're going to have, really, that's the first part of the filtration system, because, the idea is you don't want fish and debris and sticks and everything else going through that. So that's going to go ahead and be that first line of defense. So you got many different types of intakes. You have some that go out into the, the waterway, whatever it may be, and go down into the depths. That's a very common type, which is, this is, a close-up of this, but you can see they have a couple big turbine pumps. Turbine pumps, the pumps are up at the top, and there's a shaft that goes down to wherever the impellers are down at the bottom of the pumps. Here's another one. Although this one is on land, but the water tables are going to be pretty shallow here. So again, I don't know how deep this goes, but again, it shows another type of inlet that again is next to a waterway. So certainly you're drawing water out of that. And my guess is it's probably out of an unconfined aquifer, because otherwise it probably wouldn't be located right next to the water. Reservoir intakes, again, come in all different shapes and sizes. These are, major construction projects. Water infrastructure is a huge expense. And unfortunately, in California, our water infrastructure gets a D+ rating right now. Now, the silver lining on that is Proposition 1 that passed in 2014. So it's just starting, that money is just starting to hit the industry right now and all the water systems. But there's almost $8 billion that is going into our water infrastructure here in California. There's another intake. Another one. I don't know if you guys have ever been by Moccasin over on the way to Groveland, but you'll see one of these at Moccasin there at the powerhouse. Again, some really big turbine pumps. These pumps potentially can go to thousands and thousands of horsepower. Again, scalability as far as what size are they serving and how much volume do they need to pump. But again, these systems can go from tiny systems up through incredibly huge systems. There's the one at Hetch Hetchy. So reservoir management and preparation. Ideally, the removal of trees from the area to be flooded. Now, one of the things that we saw with New Maloney's is, they had not done a very good job of cleaning all those trees out. We know that from after 5 years of drought, that water level went down. We were seeing trees and brush everywhere. You want to get those trees and brush out of there because the decomposition of the trees and brush release organics. They can cause color problems with the tannins, increase chlorine demand, and the development of disinfection byproducts, DBPs, and THMs, which are trihalomethanes. This is, again, just showing that we've got, basically our tributaries coming down. We know the water cycle. Most of you have certainly understood some of this at this point with some of the classes you've taken. But we have our surface water that comes down. But then we also have some percolation that goes down into the ground. And so we have here an unconfined aquifer, which is feeding into this lake down here, whatever the waterway may be. A confined aquifer would actually be down below here, sealed in. Reservoir management. Well, we need to control the algae. And you think of algae, and typically algae is the green, but we have all different types and colors, and there's red algae blooms, and pink algae blooms, and orange algae blooms, and all kinds of algae, and they all need to be treated a little bit differently, but that's where our labs come in the analysis of what's going on. Water quality management must be economically and feasible. Be prepared for each different reservoir. Again, different water sources, different ways to treat it. And technically justifiable. So, our reservoirs vary on these big reservoirs because some of them allow boating and recreation, others don't. But again, a lot of that just depends on how close that is to the end user. You're normally going to see recreation allowed on the ones that are a little bit distance away from where the end users are. The methods vary widely based on the local conditions of stormwater runoff from highways. Unregulated pesticides and herbicides is a big deal. Recreational activities. Stormwater management. Is there a highway close by that's, dumping water into this? Again, all this water is going to become holistic completely, where it's going to be a complete cycle with everything accounted for in the future. Why reservoir management? Water quality and drainage. Issues that may lead to poor water quality. I just touched on this a little bit, but we have agricultural runoff, urban runoff, livestock grazing, industrial discharges, mining drainage. We live in the mother lode. There's all kinds of mine shafts up here that are full of polluted water. Wildfires. Well, we also have seen a lot of that with the debris, the nutrients, the silts that have come down from these major wildfires that we've had. Snowmelt. Coming down again, surface water, we end up with those turbidities, the organics, the nutrients. Wildfire, we just touched on, but again, all that contributes to poor water quality. So why reservoir management? Well, snowmelt, again, we get turbidity, organics, and nutrients. Now again, we know how important our snowmelt is, because the snowpack in the Sierra is nature's reservoir. And this is where, thank goodness, this year we're getting out of this drought. Hopefully we're going to be completely out of it. But with that being said, it's really good to see that snowpack building up in the high country. Reservoir maintenance. Manual or mechanical techniques for controlling shoreline vegetation. Again, we want to keep the vegetation down because, again, those organics make it harder to treat the water. We want to lower the water level slowly to prevent embankment slip-outs. Lined reservoirs should be drained only during low groundwater levels. Reason being, again, it'll pop. You get this water coming up from the bottom, and if it's lined, it'll be pushing that bladder up from the bottom, causing havoc. When, where, and how will you discharge your water when draining for maintenance? And again, water discharges are heavily controlled. And certainly, the state's watching a lot of this. And the state has many different agencies that actually have something to do with water. Algae blooms. Should you be concerned? Absolutely. Algae is one of the things that is one of the hardest things to deal with water. Photosynthesis equals organisms converting carbon dioxide into oxygen using sunlight for energy. As the photosynthesis decreases, it removes carbon dioxide from the solution. It converts it into a cellular matter. Well, we certainly have all seen, ponds that were covered in algae. And a lot of them get so thick, depending on where you're at, the different climates, that, they just look almost solid, like you could walk on them. They can get pretty gross. But anyway, respiration by algae increases the carbon dioxide, which lowers the pH, while photosynthesis decreases carbon dioxide, which increases the pH. These 2 points right here, remember this. When the sun is up, the pH goes up. When the sun is down, the pH goes down. So what can happen if an algae bloom is allowed to continue without chemical application? Low oxygen levels cause anaerobic conditions, hydrogen sulfide and iron manganese issues, tastes and odors, dead algae clogging the fish gills, which would create, a fish kill, as well as obviously lack of oxygen, low dissolved oxygen levels, and oxygen depletion in deeper water. The water actually goes septic, goes dead, and it won't support any life in those really big, deep areas. And if you see something in the deep areas, oftentimes, if it's septic, it's black, and it's really like rude. Anyway, for lack of better words. But it's that black septic stuff that gets down into those dead zones. So algae bloom cause taste and odor. That's the biggest single thing. It's really hard to deal with those taste and odors. Dissolved oxygen depletion, shortened filter runs. It totally affects your filters. You're clogging it up with all that debris. Organic loading. Increased pH, which means you're going to have to increase your chlorine demand, which means you're going to be creating more disinfection byproducts. So it's a cycle. So we're very concerned about that whole thing as far as just what kind of organic loading are we having, because it will increase our chlorine demand, which will increase basically the disinfection byproducts, which also get monitored, which you can get flagged for. So again, it's a complete cycle that you want to be careful of. So again, we get high levels of trihalomethanes, THMs, and increased color of the water. Copper sulfate, or another word for it is bluestone, is what you use to control algae blooms. And again, it depends on the water temperature, the species of the algae, the pH of the water, the amount of the algae, the alkalinity of the water. Copper sulfite works well in low alkalinity due to high levels of biological active copper. Higher alkalinity reduces the effectiveness of bluestone. One of the test questions that shows up on the test is, how do you apply copper sulfate to a small reservoir? Well, the answer is you go ahead and put it in a gunny sack and you tow it around behind a boat. Hey, so that's not a bad way to spend the afternoon. Controlling algae blooms. You want to keep really good records. And again, as an operator, this is part of being a responsible operator because it has several things. Number one, it's required. Number two, it's a CYA, because if you ever do have issues, you can say, hey, this is what I did right here. So you want to be actually kind of anal in developing your record-keeping system and be keeping logs. Keep those journals. It proves compliance with state, federal, and local regulations. It helps evaluate the current and historical treatment of programs. So again, you're looking at, really at historical data, and data is a very powerful tool when used correctly. Determining the intensity. Well, you know what? A laboratory is going to determine that. And it's going to give you information on the extent of the algae bloom, the intensity of the algae bloom, the species, and again, there's many different species, the water quality problems that develop with a particular algae bloom. So your lab is going to pretty much help you with guidance as far as how do you move through this problem. What else can the lab determine? Again, nutrient types, pollution types and pesticide types that are in the water, the radioactivity, the toxic materials, trihalomethane analysis. With that being said, a lab can actually test for thousands and thousands of things, which is not effective. So there's going to be, depending on who your primacy agency is, certain tests are going to be required monthly, quarterly, annually. Other issues that should concern the operator. Okay, I touched on it lightly, but screens, trash racks, log stops. Again, you've got all these series of little filtration stuff starting with these big log stops up in the big reservoirs. But you need to make sure that it stays cleaned out. The type depends on the size, the depth, the fish, the aquatic life. Again, quantity of debris, on the location of the intake structure in relation to the debris. The type depends on the algal scum and mass. The type also depends on the depth of the intake. Intake screens, again, they come in all different types and sizes, shapes. There's numerous different types. But again, this is one that you can see is designed to come up and down so they can go ahead and clean it out. Because they do need to go ahead and clean these. If they don't clean these somehow, all that mesh gets to the point that it gets clogged and it won't work. And your bottom line, have it to where you're going to burn your pumps out, everything else if they're not kept clean. So again, here's one being fabricated. And again, this is going to be, obviously vertical, up and down. That pointed point goes down into the ground. It's hard to tell from this whether this is a permanent one or whether this is one that can get pulled up and down. But again, the size and expense of these fittings are phenomenal. And again, they come in all shapes and sizes. And again, A lot of them, these big ones are designed to come up and down so they can clean them. And again, we're looking on the left. That, you can see the flange there, an open flange. That's a new new construction project going on, or a replacement. Something's going on there because normally they're just not going to pull that fitting up and down. And again, you get small ones. So here's a gal with a winch. You see the pipe on the right-hand side. And, again, you see a very crude little mesh filter over the end, but that's the kind of thing that she probably has to do this once a day and get that filter cleaned out. Maybe more, depending on, what the water conditions are. The middle of the summer, after a flood event, whatever, you might get a lot of debris. So again, monitor your systems. So issues that should concern the operator. Nutrients. What's a nutrient? Anything which is food that assimilates organisms, which promotes growth. Control the littoral zone, the area of rooted plants from the shoreline extending lakeward. The DO, dissolved oxygen depletion, in the metallineum, which is the middle zone. We have the epilinium, which is the top zone, the metallineum, and the hypominium, which is the lower zone. The metallineum, another word for that is actually thermocline. So there's a word that basically can be used for either way, but it's the middle zone. It should be controlled to minimize the iron, the manganese, the hydrogen sulfide. You want to maintain watershed management programs to control activities that may be harmful to the water. So reservoir conditions change. So you want to make sure that you've got close surveillance of the threshold odor condition. Maintain a log of the wind direction and the velocity. Again, document, document, document. Be prepared to deal with sudden taste and odor problems. Be alert for offshore winds. If the water with taste and odor problems make it through the plant, don't let it reach the customers. You got to deal with it. Reservoirs that ice over in the wintertime. Well, we certainly have some of these up in the high country, but the majority of us aren't going to be dealing with those. But if you have to, you need to make sure that the local authorities approve recreational activity on iced reservoirs. Safeguards against pollution in public toilets. You want to safeguard against leaking garbage cans. Insist on close supervision of the activities. And insist on time limits on the activities of the ice. Okay, well there you go today. That wraps up Chapter 3, Reservoirs and Intakes. And feel free to go ahead and watch this again because, again, get this stuff drowned in. A lot of these points can theoretically be showing up on those state exams. So hope everybody's having a great day. We'll talk to you soon. Bye-bye.